I have received quite a few inquiries on my DIY spot welder that I made a few months back, and many of you wanted to see me doing some real-world battery tab welding with it. And it just happened that I'm in the process of building a large battery bank for a power inverter, so I'm going to demonstrate in a few minutes. I did make some changes to the tab welder piece configuration. Originally, I was using two pieces of rather sharp electrodes. The main issue I had is that the welded area is rather small, and while it is fine for making battery packs with smaller batteries and thinner nickel strips, it is rather difficult for making large battery packs as what I'm doing now, because the weld is not as secure. So I just swapped out those tips with some copper rods instead. These copper rods are actually taken from some old soldering iron, so they are readily available. Now the configuration doesn't look very pretty because it's just temporary. I intended to, get it to work, and later on I might make it into a nice fixture. So these batteries here are actually not lithium-ion batteries, but they are lithium iron phosphate batteries. And the main difference between the lithium ion and the lithium iron phosphate is that these batteries are actually inherently safe. So in the event of a puncture and overheating and shorting, they don't burst into flames, so which makes a very good candidate for building battery banks, especially for use inside homes. Now these batteries are 32650s, so they are roughly the size, actually a little bit taller than your D cell, but these are actually I bought these from an eBay seller who sells a lot of these batteries, and these are actually relatively cheap. I think for 80 of these, a box he's selling only for $115. So it's a good price, and each of the cell is actually, let me just take one of the cell out, because these are just paper sleeves. I left them on because I don't want to short the cell by accident. So these cells, if you take a look, these are, this is marked as 13G08, 32650, and so LP355B. So this is actually for 5.5 amp hours each. And the main drawback of the lithium iron phosphate is that this chemistry only gives about 3.3 volts, 3.2 to 3.3 volts open circuit voltage, and also the capacity is lower for the same volume. So the energy density is lower, but they do have a much higher cycle life, and the exact cycle life for these batteries I don't know, but usually these kind of batteries would last at least twice as long as lithium ion ones, so roughly like 2,000 to 4,000 cycles. Anyway, so to build the battery bank, so the one I'm going to build is actually 12 volts. And so given for each 3.2 volts, I'm going to use two of these. So going to have 20 cells in each, in parallel. And the 20 cell would be add up to be roughly 110 amp hours. Well, they do sell those battery spacers for 32650, but I think I can just get away with using cardboard to hold this in shape. And the main reason for this is just so that it's easier for me to do the welding. So that is what I have so far. And by the way, so far I have welded all the other battery packs. So as you can see, here is the weld. So the plan is, after I have them all welded, I'm going to take two of these, either using wires to solder these two together, so to form a 3.2 volts and 20 batteries configuration, or I'm going to tab weld these two to make it a parallel, and then I'm going to alternate the configuration so that I can connect adjacent cells together. So all together I have 4 banks with each bank at 110 amp hour rating. So that would give me a very beefy battery, and hopefully I can hook it up with an inverter to power the house when the electricity is out. Okay, so now I know what you guys are all waiting for, so I'm gonna jump right into making the battery tab. So basically, as I mentioned earlier, I put them in group of 10 so that it's easier for me to hold these in place. So for the welding, I'm going to use this nickel strip. These are actually pretty nice quality. I also got on eBay, and you can find them, I think, many different sellers also the same thing. But these are actually the wider ones and thicker ones. So for these larger batteries, I think that's probably more beneficial. So I'm going to cut these in to the right length, and so altogether I need 4 pieces. I'm going to have 2 on the top and 2 at the bottom. So 1, and 4. So that's what I'm going to do for now. And let me change the camera a little bit so that I'm going to shoot from above so you can see it more clearly. Okay, so now let's do the top side for one side of the batteries. And for that, I'm just gonna place this strip on here like so. And by the way, so you can see here, this is a momentary switch I just mounted right here. So when I press this, it will start, it will close the circuit. And I set it to go about 0.5 seconds also. And you know, this is just some trial and error. Basically, I found this is the duration that produces the best weld for me, at least for this probe. So I will do it like this so you can see. So basically, I just press this, and now it's welded. And to make it more secure, I'm going to do multiple welds. So I'm going to do 2 at a time. And as you can see, the first one is welded, and now we're just going to move on. So I'm just going to do the second. Sorry, this is not on it. 2. And I might adjust it to be a little longer, the duration. So as you can see that it's rather quick. So now I have gone through the first side, and we're going to use the same technique. Got to do the other side here. A little bit short on the wire. I think it's because I actually didn't press it down enough, but that's alright. So now you can see that the top is all welded together, and of course later on I'm going to add the parallel strips. And but for the time being, let's take a look at the bottom. So for the bottom, it's the same way. Except it's a lot easier than the top because we have a much bigger area to work with. So as you can see, it's really quick. And for the next one, I'm going to lower the camera a little bit so you can see the actual the spot that I welded. And as you can see, now we have the main, the 4 strips already welded. So now I'm just gonna cut some strips that to parallel these up. By the way, I forgot to show you, but these batteries actually, they are very, all these batteries, the charge states are pretty much identical. Actually, they differ from each other by 1 millivolt or so. Since I already welded all these 5 together, I can't show you that, but I can show you the difference between these 2 banks. So it is always a good idea to check that before you solder it together, so that you will know whether or not the to prevent any problems. Because if they have let's say half a volt difference, then you're gonna create some problem. Anyway, so let's see the first bank. So let's bring it this way. The first bank is here. It's 3.332. Okay, so second bank at the bottom, also 3.332. So you can see that the batteries in this at least the batch is very uniform. So which is a good thing. And typically when you make a battery bank, you want it to make sure that all these batteries are similar in quality and similar in their physical state, so that during your use they will wear down similarly, rather than one is significantly weaker than the other, which is gonna cause your battery pack not to function as well. And sometimes if you think like 2 of the spots are not 2 weld points are not good enough, we can certainly do more, especially on the top side. The top side is a little bit of tricky because the contact area is smaller, so it's harder to work with. So we may, just do another round so to make it stronger. So let's just add 1. And these wires are sufficient, so they're not that warm. So a little bit about the welding. A lot of people say that it's really how much energy you deposit into the welding point. And the typical weld for this size is somewhere between 100 joule and 200 joule. So the current through this measured through this cable is actually at about 300 amps. And so for 1 second it would be 300 joules. So we're slightly under a second. So we are actually at the higher end of that 200 joule. Again, it is totally depends on the situation you are working with, and depends on the material you are using. Sometimes there could be a significant difference. So now we can move on to weld the top to parallel these 2 sides together. Now, I had some strips from before when I was welding the bottom for the other battery banks, and you can see that these are actually not long enough. So what I can do is actually to join these 2 pieces together using the welder here. So I'll show you. Let me move this out of the way. So I can use the main welder here. And this is where it comes handy. So basically we put these 2 together And I'm not sure you can see. Well, let's move the camera so you can see the weld. Okay, so now it's on under there. I just press this. So this weld is actually very secure, and I'm going to do a couple of these here so that so there. So now you can see that we just made ourselves a longer strip, and it is you know, as good as before. So now I'm going to use this strip to weld the top to parallel these two together. So I'm going to leave this one as is, because actually the other ones I did not weld the last one, because I think I might, depends on how I plan to do it later, I might either solder wires on between the batteries and bridge them over, or I can use another, you know, use this strip to connect the two. I haven't decided yet, but we will wait and see. So let's take care of the bottom side. And the bottom side is, you know, we can use, for example, the leftover strips to connect directly together. And some of these are actually too long, so we're gonna trim it a little bit. But I think I'm gonna use, hang on, so let me trim this a little bit. And so that should be good enough for this one. Yep. So what we want to do is just like that. And now the first one is nicely connected. And let's see, we have, yeah, all these are a little bit too long. Okay, so let me cut them down a little bit. Now the reason I didn't put this tab over the already soldered tab is that sometimes, you know, you have too thick of the tab material. What happens is the connection is going to be difficult to connect, and also the nickel strips have slightly higher resistance than, say, copper and other materials. So you don't want to make it too thick. So, as you can see, that another group of battery is done. So this spot welder, actually, I'm very satisfied, and the ability to adjust the duration of the weld is very important, because too long of a weld, you are going to either melt the tab or generate too much heat and damage your battery. Too little, you would have the problem of not going to make a proper weld. So as you can see, that now I have all the 8 groups ready here. So all the 8 groups. My next step is I think I'm going to plan to build a case and properly wire them together and add a battery management module. And I'm sure I will make another video to show you guys when I'm about done. And we will go from there. So I hope you enjoyed the video, and hope you learned something. And if you liked the video, please give it a big thumbs up. and please remember to share. I will catch up with you next time.